Welcome again to Monitor Field Academy. Today I'm going to take you through the way we solve probability problems by using tree diagrams. Now let us see this example. Our example states that in a family of 3 children, use a tree diagram to find 1. The probability that all children are boys. 2. The probability that all children are girls. 3. The probability that 2 are girls and 1 is a boy. 4th, the probability that at least 1 is a girl. The 5th part is the probability that at least 2 are boys. So after we've read the question, let us now see a solution. Let us see the solution. As we know, within a family there are children. A child can be a girl or a boy. Now, the first child can be a boy or a girl. What about a second child? A second child also can be a boy or a girl. A second child can be also a boy or a girl. A boy or a girl. What about a third child? A third child also can be a boy or a girl. A boy or a girl. A boy or a girl. Boy or girl. Boy or girl. Now, this is a tree diagram. As you can see, we have a line for the first child, second child, and third child, as we are told that this family has 3 children. Now, let us see the different possible combinations of 3 children within this family. These possible combinations are, as you see, we have the first combination is boy, boy, boy. Boy, boy, boy. Our second combination is boy, boy, girl. We have boy, boy, girl. Our third combination is boy, girl, boy. Boy, girl, boy. Our fourth combination is boy, girl, girl. Boy, girl, girl. Our fifth combination is girl, boy, boy. Girl, boy, boy. Our sixth combination is girl, boy, girl. Girl, boy, girl. Our seventh combination is girl, girl, boy. Girl, girl, boy. The last combination, which is the eighth combination, possible combination is girl, girl, girl. Girl, girl, girl. So, we find that from this tree diagram, we have 8 total possible combinations. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 different ways from which we can get these 3 children. Now here we say that from this tree diagram, the number of sample space is equal to 8. Why do we say that the number of sample space is equal to 8? Because we have 8 is the total possible combination. So this is the number of sample space. Now let us start with these different events, the probability of these different events. The event number 1 is to get all children boys. All children boys. Number one, to get all children boys. How many combinations do we have all children boys? We have the first one, boy, boy, boy. All 3 are boys. Is there any other combination whereby we get all 3 boys? No. So in Roman 1, we say that the number of events is equal to the number that all are boys. All are boys. All are boys. Which will be equal to 1. As you can see, we have only one combination whereby all three children are boys. So, what is the probability of getting all 3 children boys? We say that probability, we say that probability of an event is equal to number of events over number of sample space, number of sample space. So here we say that the probability of getting all children or boys, or are boys, probability of getting all children being boys will be equal to the number of event, whereby it is 1 over number of sample space, which is 8. So it is 1 over 8. Now we say that the probability that all three children are boys is equal to 1 over 8. This will be the answer. So we are through with the first part. Now let us go to the second part of our question, which is to find the probability that all children are girls. Find the probability that all children are girls. Now, to find the probability that all 3 children are girls, you may pass across these possible outcomes, which are 8. Now, where have we obtained all 3 children girls? It is only one combination, this one, girl, girl, girl. If we pass the remaining 7 combinations, there is no any combination which possesses all 3 girls. So we have only one combination. Now, Roman 2, in Roman 2, we say that the number of events is equal to number that all are girls. All 3 children are girls. Now, this will be equal to how many? We have only one combination. This one, girl, girl, girl. But the number of sample space is equal to 8. So we say that from probability of an event, we say that probability of an event is equal to number of events over number of sample space. So for the case of our problem, it will be equal to number. Our event is the number of all 3 children are girls, or are girls, over number of sample space. So this will be equal to, how many do we have? We have number of events 1. 1 possibility over total number, we have 8, which is number of sample space. So the probability, now the probability that all are girls is equal to 1 over 8. So this is, now we are through with the second part of our question. Let us go to our third part. Our third part states that to find the probability that 2 are girls and 1 is a boy. 2 girls and 1 boy. 2 girls and 1 boy. Now let us see the way we deal with this one. Let us see the way we deal with it. Here in our third part of our question, number of events is equal to the probability that 2 are girls and 1 is a boy. So to get 2 children being girls and 1 boy, so number that 2 are girls and 1 boy. 1 is a boy. 1 is a boy. This will be equal to how many? Here, let us find out all possible outcomes which contain 2 girls and 1 boy. 2 girls and 1 boy. The first one, boy, 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 so that is not 1. 2 girls and 1 boy. This is 2 boys, boy, boy, girl, so it is not 1. here we have two boys, boy, girl, boy, two boys and one girl. What are we asking? Two girls. So even this is not. Here we have boy, girl, girl. We have two girls and one boy. Yes, this one. This is the first one. One boy and two girls. A second possible way. This one, girl, boy, boy. Not girl, boy, girl. We have two girls and one boy. Even this is the second possible outcome. Also, we have. This is a second possible. This is a second possible event. Also, we have here girl, girl, boy, girl, girl, boy. Even here, we have two girls, one boy. A third event. Here we have girl, girl, girl. So we have only three chances which contain two girls and one boy. So here the number of events will be equal to 3. What about number of sample space? As usual, number of sample space is equal to 8 because this number of events are from number of sample space is equal to 8. Now, probability of an event is equal to number of events over number of sample space. Now, how many events do we have? 3. Number of sample space 8. So it will be equal to 3 over 8. Now, the probability of getting 2 girls and 1 boy is equal to 3 over 8. Now, the probability that 2 children are girls and 1 is a boy and 1 is a boy is equal to 3 over 8 is equal to 3 over 8. This is the probability of getting 2 girls and 1 boy within this family which has 3 children. Now we are through with our third part of our question. Let us go to our fourth part. Our fourth part of our question requires to find the probability that at least 1 is a girl. At least 1 child is a girl. At least 1 child is a girl. When we are told at least, it means that the number of children who are girls within this family should start from 1. It means that we may find maybe a family has 3 children, but 1 is a girl, or 2 are girls, or all 3 are girls. Because when you speak about at least, it means that that is the minimum number to start with when you take into consideration. Now, it means that within a combination to be taken, at least 1 should be a girl. So we can find that within a combination there is 1 girl, 2 girls, or 3 girls. Any of these 3 possible ways, either 1 girl or 2 girls, or all 3 girls, or all 3 children being girls. Now, which are those combinations? The first one is not true because it is boy, boy, boy. Second, boy, boy, girl. This is the one because there is 1 girl. Here, third combination of boy, girl, boy. There is a girl, so we take it. The second event, a third event, boy, girl, girl. Even this is taken because we have 2 girls. Fourth one, we have girl, boy, boy. Even this is taken because there is girls here. Girl, boy, girl. So as there are 2 girls, even this is taken. Girl, girl, boy is taken also. Girl, girl, girl is also taken. So the possible ways we have 7 ways. So the number of events will be 7. As we see, in these 7 combination, there is at least 1 girl. Now, Roman 4. Number of events is equal to number of at least 1 is a girl. At least 1 child is a girl. So the number of events we have obtained that we have 7 possible ways whereby there is at least 1 girl. 7 possible ways. So here let us see the probability of getting at least one being a girl within this family. Now here we say probability of an event is equal to number of events over number of sample space. Now it will be equal to number of events which we have 7, number of sample space 8. Now probability will be 7 over 8. So we say the probability that at least one child is a girl will be equal to 7 over 8. So this will be the solution for the fourth part. Now after we've dealt with the fourth part, let us go to the last part, whereby we are going to deal with the probability that at least 2 are boys. Probability that at least 2 children are boys. Now, how do we deal with this? Let us see this last section. So here, number 5, Roman 5, we are given that the number of events is equal to, probability that at least 2 are boys. So it means that the combination which is taken here among the possible events is any combination which has 2 boys or more, but the number of boys should start from 2. Now let us see those families. Those possible combination whereby we have at least 2 boys. We have the first one because we have 3 boys, boy, boy. So there are 2 boys. We have all 3 boys, so it means that 2 boys at least are there. Boy, girl, even this is taken the second one. Boy is taken because it is 2 boys. This is the third event. Boy, girl is not taken because there is only one boy. Girl, boy. This is taken because we have 2 boys. Girl, boy. This is not taken because we have 1 boy. Girl, boy is not taken because we have 2 girls. Girl is not taken because we haven't at least 2 boys here. Now the possible ways, the total number of events we have 1, 2, 3. So we have only 3 where we have at least 2 boys. No, not only 3. 1, 2, 3, 4. We have 4 possible ways. Now, number of events will be equal to number that at least 2 are boys. So we have 1, 2, 3, 4. We have 4 ways. We have different 4 ways whereby at least 2 children are boys. Now, this is the number of events from the probability of an event. Probability of an event is equal to number of events over number of sample space. Now, it will be equal to number of events. Number of events we have 4 over 8, which is number of sample space. When we simplify, we get 1 over 2. So, we say that the probability that at least 2 children are boys is equal to 1 over 2, a half. So we are through with this problem, which was instructing us on the way we use tree diagrams on dealing with the problems of probability. Thank you for attending today's session. I welcome you in the next sessions. Have a nice moment. Bye.